In just a few hours, the strange green glowing traveler known as 3I, ATLAS will make its closest pass to Mars. A moment that could reshape everything we think we know about comets, interstellar wanderers, and perhaps even life beyond our solar system. This is not a rehearsal. This is the real event, a test of months of speculation, sleepless analysis, and whispered theories. What happens next will either confirm humanity's most daring suspicions or return this mystery to the comfort of known science, a story of ice, rock, and cosmic dust. From the beginning, 3I, ATLAS refused to behave like any comet astronomers have ever recorded. Its discovery was not a quiet one. Instead of following a predictable brightening curve as it neared the Sun, its light fluctuated wildly, pulsing brighter and dimmer in a pattern no natural heating could explain. Spectral readings showed something stranger still. Dominant bands of carbon dioxide where ordinary comets display water vapor first. The dust it shed didn't disperse normally either, it moved in slow, deliberate patterns, as though shaped by some hidden hand. And then came the color, an otherworldly emerald glow that refused every chemical explanation we could think of. Theories emerged like waves: exotic minerals, magnetic storms, electrostatic flares, or something else entirely. In quiet rooms, a few scientists began to speak words they normally avoid: engineered probe, reconnaissance object, non-natural behavior. Tonight, those unspoken ideas will be tested. As 3I, ATLAS crosses Mars' orbit, Earth will lose direct visibility. For a brief, crucial window, our planet will be blind. Only the orbiters circling the red planet, MAVEN, TGO, Mars Express, along with a few solar observatories, will keep their eyes open. Every available instrument has been redirected for this moment. Rovers on the surface, if conditions permit, will lift their cameras to the Martian sky, recording data that could define the next great mystery in astronomy. Astronomers often try to turn the extraordinary into the ordinary, to fit the strange into the comfort of physics. That effort continues tonight. Many believe 3I, ATLAS is simply a highly active interstellar comet, born in a distant, carbon-rich system where volatile ices erupt under unfamiliar sunlight. Others propose that magnetic interactions are sculpting its tail into unnatural shapes. These explanations make sense, but none of them yet hold proof. Still, three unsettling features remain, each one difficult to ignore. First, its path. 3I, ATLAS moves almost perfectly along the plane of our planets, an unlikely precision for something from outside the solar system. Second, its pulse. Instead of a smooth brightening curve, it flickers rhythmically, intervals that match subtle, measurable accelerations. Third, its chemistry. The strange balance of carbon dioxide and fleeting metallic traces hint at materials unseen in any known catalog of comets. Separately, these could be coincidences. Together, they suggest intention, or at least, something unprecedented in natural behavior. As the moment of closest approach arrives, scientists are watching for three possible outcomes. Scenario 1, fragmentation. If the object breaks apart, the pattern of fragments will tell the story of its structure, whether it's brittle rock, volatile ice, or something far more exotic. Scenario 2, path deviation. Even the smallest shift from its expected orbit could reveal internal propulsion or jets that do not behave according to sunlight alone. Scenario 3, spectral anomalies. If orbiters detect radiation or ionized gases outside the range of normal sublimation, the implications would be extraordinary. Mars itself becomes the stage for this cosmic event. Its thin air and faint magnetic field make it the perfect laboratory to observe how an interstellar body interacts with a planet. A glancing fragment could ignite brief auroras or distort its ionosphere, momentary signs of something never before seen. Data from MAVEN and TGO will trickle in after a delay, each transmission a potential revelation. Isotopic traces, charged particle counts, dust composition. The raw truth of what 3I, ATLAS really is. But there's another, quieter concern: contamination. If 3I, ATLAS carries complex carbon chains, amino precursors, or even microscopic structures, fragments landing on Mars could blur the line between Martian and interstellar chemistry. Future missions searching for life would face an impossible puzzle. Which molecules belong to Mars, and which fell from the stars? Tension already simmers behind the scenes. Some scientists demand all data be released publicly. Others urge caution, or even classification. Inside Mission Control, the atmosphere feels more like a command center than a lab. Engineers run final diagnostics, while analysts ready redundant uplinks. Across Earth, amateur astronomers align telescopes, synchronizing in real time with professional observatories. Citizen scientists have built automated systems to upload raw images the moment they're captured, sometimes faster than official channels can confirm them. A single frame from a backyard telescope could rewrite what we know before the agencies even respond. The future now branches into three paths. In the first, the most ordinary outcome, 3I, ATLAS behaves like a comet, erratic, natural, but still explainable. It flares, maybe fragments, and drifts on, leaving behind data and wonder. In the second, it shatters violently, scattering debris through Mars' orbit. A dangerous cloud of fragments could strike orbiters or pepper the planet's thin atmosphere with interstellar dust. And in the third, the one that makes even the calmest scientists restless, it refuses to fit the model. If its light pulses match its motion, or if it emits frequencies no comet should, then the word engineered may no longer be off limits, not as belief, but as a hypothesis. Still, science demands discipline. Extraordinary claims require extraordinary proof. Both Hubble and the James Webb Space Telescope have already completed their final observations before conjunction. Ground-based arrays continue to listen for signals hidden in the static. Every instrument on Earth and beyond is now tuned to one frequency: curiosity. For the public, the night will feel surreal, awe mixed with uncertainty. We'll know Earth's view is blocked, yet we'll keep watching the skies, waiting for the first images to return. Rumors will ripple across social media. Theories will multiply faster than data. But in science, patience is everything. Whether 3I, ATLAS turns out to be a volatile relic of another star system or something that defies natural classification, one thing is certain: the story of our connection to the galaxy will change. If fragments fall upon Mars, we may soon study the first direct samples of material born beyond our Sun. If it reveals behavior that cannot be explained, then we face a deeper question about what, or who, travels between the stars. Either way, discovery wins. Tonight, the universe reminds us of something simple and profound: it is not silent. It is alive with questions. So look up, not just for answers but for possibilities. Watch the skies above Mars. Follow the faint flashes of light that mark the passage of an interstellar messenger. For in its emerald glow, we might glimpse a reflection of ourselves, or the echo of something waiting to be understood. The cosmos still keeps its secrets. And humanity, as always, is listening.